One other example that I think will be particularly useful to you is the weighted mean. Some folks don't know how to calculate their GPA. What hurts your GPA more, an F in biology or an F in fitness walking? Or are they the same? F in biology, why? It's a 4-hour course where fitness walking is only a 1-hour course. So your GPA is a weighted mean because your grade in each course is weighted with the number of course hours of each course. You multiply the weight times each data value and divide by the total weight. Your average for this course at the end of the semester is also a weighted average because your tests count way more than your homework or your study guide. I will multiply, what do I have in the syllabus? 80, is it 80, 10, and 10 or 85? I think let's say it's 80, 10, and 10, and I'll look it up before I actually calculate your grade. But if the tests count 80% of your grade, and let's say you have a test average of 90, then I'm going to multiply 0.8 times 90. And I'll do that for your homework and for your study guide. And I have set all those weights up to equal 100. So I just divide by 100. But in some other situation, the weights may not add up to 100. Let's calculate the GPA for this student. 80, 15, and 5. Yeah, I don't want the study guide to count it as much as your homework. That's good. But it's different for each of my classes, so I have to look it up when I need to. All right, this student had a pretty good load this semester. Took Comp 1, Biology 1, Statistics, American History, and PE for a total of how many credit hours? Yeah, 14 credit hours. Good, solid load. Oh gosh, this was probably me. Well, I made an E in all my maths. E? We didn't have E's. I made an A in all my maths, A in all my Englishes, A's in all my histories. Came darn close to failing tennis because I am so uncoordinated. My husband likes to throw things at my head just to watch me go right after they smack me in the forehead. Actually, I made a B in tennis because of, thank God for written tests. I can memorize and spew back anything you want. I just can't hit the ball. And broke my pinky toe doing it. I'm so glad I only had to have 2 PEs. All right, let's calculate this person's GPA. In college, an A is 4 quality points. I've got this at the top for you. An A is 4 quality points. A C is 2 quality points. An A is 4. A B is 3. And F is 0. So I need to multiply each credit hour times the number of points that you got for your letter grade in that class. I earned 12 quality points for my English class. 4 times 2 is 8 quality points for biology. 3 times 4 is 12 quality points for statistics. 3 times 3 is 9 quality points for history, and 0 credit points or quality points for PE. How many quality points does this person make this semester? 32, 41, I think. This person's GPA is just the sum of all the quality points divided by the number of credit hours you take. So 41 divided by 14, this person's GPA to the nearest, say, 2 decimal places is what? So you second that? 2.93. Little bit low for the lottery scholarship, but plenty high enough to keep you out of trouble with Pell Grant. GPA of 2.93, do just a little bit better next semester, and the lottery scholarship will be okay again. All right. Any questions about GPA as a weighted average? So we've done that. Best measure of center. Well, each measure of center has its advantages and disadvantages. This chart shows you how to find the mean, how to find the median, how to find the mode and the mid-range. And then below that gives you the advantages and disadvantages of each. The mean is good because it samples from the same population have very similar means, but the disadvantage is it's very sensitive to outliers. A median is good if there are some extreme values because it's less sensitive to the outliers. And the mode is good for nominal levels of measurement. That's pretty much the only time I would use mode is if I have nominal data and I can't add them up and divide by how many there are. And then the mid-range, only time I'd use it is when all I was given was the highest value and the lowest value. So my best measure of center would just be to average those two, but I wouldn't bet any money on it. It may not be a very good reflection of the actual measure of center for that data. All right. End on a cartoon. In retrospect, it was clear why Jack was bragging about the mean height of his beanstalks rather than the median. Somebody explain that to me. I don't get it. How would he find the mean height of his beanstalks? How do you find the mean? No. Mean is just measure each of the beanstalks, add up all the heights, divide by the total number of beanstalks. That would be the mean height of the beanstalks. How do you find the median height of the beanstalks? All right, I'm going to make you explain this cartoon for your reading quiz. What did you say? All right, if he put all these beanstalks in order, then the middle one is going to be one of these guys. But if he finds the height of all the beanstalks with that one huge beanstalk, adds them all up, that outlier is drastically going to skew the mean where it wouldn't affect the median at all. I don't know. Cartoon may not be good if you have to explain it, but the more you know in statistics, the funnier these cartoons get. There are two more words. We've used the word symmetric to describe data. For example, when we said data was normally distributed, it reaches a high point and then the right-hand side tapers off roughly a mirror image of the left-hand side. That is symmetric data. And if the data is symmetric, then, if it reaches a high point and the left side and the right side are symmetric, then you say this is a symmetric data set or a normal distribution. Skewed is just when it's not symmetric left and right, when it's leaning more one way than the other. And when you talk about skewness, you can talk about data which is skewed to the left or skewed to the right. These definitions are straight out of the book. It's not necessarily the easiest way for me to determine whether something is skewed to the left or skewed to the right. Let's talk about the book's way of telling and then my way. Skewed to the left, also called negatively skewed, have a longer left tail. Again, if you draw the normal distribution, the left and right sides are mirror images of each other, but skewed to the left would have a longer tail on the left than normal would, and the mean and the median are to the left of the mode. Skewed to the right has a longer right tail, and the mean and the median are to the right of the mode. Maybe you totally get that and are fine with it, but these next two examples, let me tell you how I think about it. Here are pictures of a data set that is symmetric, and if it's symmetric, the mean, the median, and the mode are all the same. This graph comes from some data that is skewed to the left. Yes, it does have a longer left tail, and the mean and the median are to the left of the mode, and then that's a picture of skewed to the right or positively skewed. But here come the examples. Let's talk about these examples, and then if you still have a question, we'll go back to it. This is a better way for me to think of, is it positively skewed or negatively skewed? If the New York Yankees baseball team of 2006 had a mean salary of $7 million, but the mode was closer to $3 million, how could that even happen? How could the mean be 7 and the mode only be 3? This is Nick Saban coaching the New York Yankees, or playing on the New York Yankees. One really high salary dragged the mean up. When I'm thinking drag the mean up, that's positively skewed or skewed to the right. That's the easiest way for me to think of it. If one really high value, one high outlier is raising the mean, then that's positively skewed. And in the second example, I have scores on a math exam. How could the mean be 68, but the mode, which is the greatest frequency, more people made 75s on the test than anything else? How could these two be different? How could the mean be lower than what most people made? Somebody made a really low grade, even though most folks made 75, that really low grade dragged the mean down. And whenever I think drag down, I think that's negatively skewed or skewed to the left. All right, so we talked about different measures of center, mean from a frequency distribution, weighted mean, best measures of center, and skewness.